Recording, okay. Or, another way you could say that is like, how do we factor the hard way, right? When a thing doesn't look like it's going to factor. And the answer is we divide, because factoring is splitting a thing up into a product, right? So division would be, well, okay, if I know sort of partial information, how do I find the rest of it? The answer would be division. So first, just a little bit of like terminology stuff, because we're going to use it. The thing that you're dividing is called the dividend. The thing that you're dividing by is the divisor. And then the answer, the whole part of the answer is the quotient, and then there's a remainder left over, right? So I gave you like a little example here. If you divide 7 by 3, 3 goes into 7 2 whole times, right? 2 times 3 is 6, and then leaves a remainder 1. So the quotient is 2, the remainder is 1, which we can write as 2 plus a third, or is like a mixed number like 2 and 1/3, right? So what we're going to be looking at is how division works for polynomials. There are a couple of ways that we can do this, and we'll get to the like mechanics in a second. But the thing that we're relying on is there's this, kind of general result called the remainder theorem that says if you take a polynomial and divide it by something that looks like x minus k, k is just some number, then the remainder of that is the same thing as f of k. So it's the same thing you would get if you plugged, if you plug 2 into the function. If you take f and divide it by, say, x minus 2, the remainder would be the same thing as f of 2. That's whatever. It's a thing. It's a result that's true. It's sort of a questionable usefulness, except that a special result of that is the factor theorem. The factor theorem is the thing that we've been leaning on for the last week and a half or something to solve things, right? Because if we have a factored thing, if we have a factored thing, then we know zero product property says I can split those up and set them equal to 0 and solve, right? Nope. The factor theorem says that a polynomial has x minus k as a factor if and only if f of k equals 0. What that means is that not only can we go that direction, like starting from the factor thing and working down, but we can also go back up, right? Which is what we've been using kind of implicitly to do stuff like what we just did with the graph. If I know the zeros, then I know the factors. It's because of this. So what that means is that if a thing divides into a polynomial like cleanly, like leaving remainder 0, then what that does is tell us how to factor it. And if it tells us how to factor it, then we can, break it down into a smaller thing that we can solve. Okay, so we're going to start with kind of a big example. So graph this thing. Grab, calculator, Desmos, whatever, graph that. Three x. All right, so what you see by default in the standard window of your calculator or Desmos is about something like that, right? Which is not really all that helpful, right? Like what kind of a thing is this? Look at the leading term. What can we say about it? Positive. The leading term is 3x cubed. So the degree is 3. So what do the ends look like if it's leading term is positive and the degree is 3? The ends look like that, right? Okay, and probably since it's degree 3, there's probably 3 places where it crosses the axis, right? Unless there's something like it bounces off somewhere. like, I know that somewhere out there, this thing is, you know, sort of a big loopy kind of thing like that, right? But what I see in the standard window is, well, just this, I don't know, those things look like almost vertical, right? So, and I mean, looking at the function, like the coefficients are big, right? This thing is probably kind of way out somewhere. So I can either kind of mess around with zooming and stuff, but when you do that, you know, because usually when you do it, you kind of do it equally in both directions. So like, it's hard to get a good idea for a good picture of what this looks like, right? So if I'm trying to solve that and find the zeros, well, like I got this, I can maybe mess around and look at the graph, but what I can tell, what I can get pretty easily from this and like feel confident about are those two things, right? Now, one of those Desmos or calculator tells me is -2. The other one says it's 0.667, right? Okay, so one of them lands on like a nice integer value. The other one is some kind of decimal thing. You've seen enough at this point probably to like not trust that very much, right? Because like, is it the calculator rounding somewhere? Is that really what it is? Is it 2/3? Like, I don't really know. -2, I feel good about though, right? And again, if I mess around with the graph some more, there's another one way out here at 50, but again, like I got to go find that, right? So if we're talking about the zeros, x equals -2, that one I feel pretty good about. The other two, 2/3 maybe, and 50, like those I don't feel as good about. Because those I had to go look for. I had to, you know, rely on like the way the calculator's rounding things here, maybe, like, is it really 2/3? I don't know. So we have 1, 0. There are 3. I have no idea how to factor that thing, right? Because look at it, 3x cubed minus 146x squared minus 204x plus 200. Like, none of our factoring tricks are going to work there, right? There are no common factors. It's got 4 terms, so we might think about grouping, but is grouping going to work there? You'd have to like sort of pair these up and pair those up, right? Well, these coefficients are pretty far apart, so if I find a common factor to take out there, like, okay, whatever, but these are pretty close together. So there's no way that I'm going to be able to get those to like match up and leave the same stuff behind, right? To do the sort of like second factoring step when you group. So we're kind of like out of luck at this point, right? This is where division comes in. This is where the factor theorem thing comes in. What that theorem says, what that result says, is that if you know 1, 0, which we do, right? We feel good about that. And I'm saying like, we can feel confident about that. And if you look at the way some of the other problems are worded, like, I'm going to give you a 0. We feel good about this one. The thing is degree 3. So if I could take a linear factor out of it, what's going to be left behind is quadratic. And we know everything about solving quadratics, right? So if I know this, then if I can figure out how to take that factor that goes with it out of the thing, if I can figure out how to factor it without knowing how to factor it, then we're in good shape. That's where division comes in. Division is the way that you factor when you don't know how to factor, right? This is the like brute force approach to factoring a thing. So let's take a look at just how the like mechanics of this work. How do you divide numbers? Like say I want to divide 3 into 20. No, 3 into 47. What do we do? Look at how that goes into that. 3 goes into 4 once. Then you multiply, right? 1 times 3 is 3. Subtract. 4 minus 3 is 1. So I carry that down, right? 3 doesn't go into 1, which is good because if it did, that would mean that I, goofed up the step before. 3 doesn't go into 1, so I carry the next thing down. How many times does 3 go into 17? 5. And then we do this again, right? I multiply, I bring that down. 3 times 5 is 15. We subtract. 17 minus 15 is 2. There's nothing left to carry down, and I'm not going to get into decimals and stuff. So this is the remainder then. So 47 divided by 3 is 15, remainder 2. So plus 2/3. Quotient and remainder. Okay, so that's how it works for, numbers, for dividing integers. The way division works for polynomials is pretty much the same idea. It's gonna, of course, like look and feel a little bit different, but hopefully after you do it a few times, you get a feel for it, being basically the same thing. Let's take a look at number 1 down there at the bottom of the first page. X squared plus 2x minus 3 over x plus 4. So x plus 4 into x squared plus 2x minus 3. Okay, so the way this goes is that we again pretty much look at like how the divisor, the thing you're dividing by, goes into the thing and kind of doing it one term at a time. So what I'm going to do is look at this and this and ask, what do I need to multiply this by to get that? Or, flip side, what's this divided by that? X. Right, so just comparing the leading terms there. X goes into x squared x times, or this times this gives you that, right? So you got to match the power, you got to match the coefficient. Then just like we did before, we're going to multiply, right? So I'm going to take this, I'm going to multiply by this, and bring it down here. So what's x times x plus 4? X squared plus 4x. Then we subtract. So I've got things kind of lined up so that we're combining like terms here. If you see stuff where like a term doesn't appear, then you might just want to be a little bit careful about that. What's this minus this? Well, x squared minus x squared is 0. That's good because just like with dividing, numbers, we want things to be sort of simplifying as we go, right? So like things should be, dropping off. So that's 0, that's good. 2x minus 4x. Negative 2x, right? Just combine them like terms. And then negative 3 minus, well, there's nothing there, so treat it like negative 3 minus 0. Right, like there's a 0 in that place. All right, so let's just walk back through that real quick. Leading term into leading term, x times. Once you have this, you multiply, carry down, subtract, and then just carefully, subtract term by term, combining like things. That gets us here. Now again, just like we did with, dividing two numbers, now you just do it all over again. You just forget about this stuff because we've already done it. Look at this and this and repeat the process. So now I'm looking at how this leading term goes into this leading term. So negative 2x divided by x, or what do I need to multiply this by to get that? Negative 2. Take the thing that we just added, multiply, bring it down. So negative 2 times x plus 4 would be negative 2x minus 8. And then subtract. Negative 2x minus negative 2x, well, that would become negative 2x plus 2x. So those cancel, right? Those add out. Negative 3 minus negative 8, so negative 3 plus 8, so 5. You keep doing this until you can't anymore, until this thing doesn't go into that thing. Does this thing go into that thing? No, so we stop. That's the remainder. So x squared plus 2x minus 3 divided by x plus 4 is x minus 2 with remainder 5. Which I could write like that, right? And just think about it the same way you would like a mixed number. It's the whole number of times that it went in plus the remainder over whatever you were dividing by. The just to kind of point it out, and let me just give you the honest assessment of this. I'm never going to make a huge deal about the remainder theorem part of things because it's sort of weird and questionably useful. There's like one problem in my notes. There are maybe like 2 in the homework where it asks you something about the remainder theorem. What the remainder theorem tells you here is that dividing, how do you spell dividing? Yes. Dividing x squared. I just have one of those weird brain things. Like, is that my name? You ever do that? Like you write your name down, you're like, no, just me? Okay, cool, great. Dividing that by x plus 4 gives remainder 5. That means that plugging negative 4 into that, right? Let me call this f. That means that f of negative 4 is 5. And you can check if you plug negative 4 into that, you get 16 minus 8 minus 3, you get 5, right? So that's the remainder theorem. Like those two things are the same. So if you see a thing ask about remainder theorem, like you can check your answer by just plugging the value in and see what you get. But the more important thing that we're going to care a lot more about is the factor theorem when that happens to 0. More importantly, though, the division part of this. One, there are about 1 million places there where you can make some dumb little arithmetic mistake that throws the whole thing off, right? So just slow down a little bit. There's going to be, I haven't actually written the test yet, but probably there will be like one question where you have to do this. So just take an extra, minute or something, slow down a little, and just be careful with the arithmetic, because if you make a mistake here, all the rest of it is going to be off. And it's really hard to go back and find, where you just did some stupid arithmetic thing, like 2 plus 3 is 4 instead of 5 or something, right? That's the kind of mistake that you make most of the time. And those are really hard to catch. And even if you do catch it, it's hard to fix it in the middle of the problem. You pretty much just have to toss it and start over. So just be careful about that. The flip side, and I'll talk about this some more in a minute too, but is to just, if something like that happens and you don't have time to fix it, just show me that kind of big picture what should be going on, right? Because I want to give you partial credit, but it's hard for me to do that if all you do is 2 steps and then you failed and I can't tell, what you were trying to do. So yeah. Now the other way that you can do this is using synthetic division. Just for the sake of doing it, let's walk through that real quick. Synthetic division, you take the thing that you're dividing, right? The dividend, you take the coefficients off. So 1, 2, and -3. Draw some kind of a thing. I don't know, like that maybe. And then take this part of it, right? So think about that x plus 4 like factor. Think about it like as where the 0 comes from, which will be -4, right? Synthetic division is kind of just a like shortened version of keeping the books. Like you do all the same stuff basically. It's just kind of, you know, writing less stuff down. The way this works though, you carry the first thing down. And then multiply this times this. So -4 times 1 is -4. And then you add, right? So sort of within the column there, you add 2 plus -4 is -2. Multiply these two. -4 and -2 is 8. Add again. -3 plus 8 is 5. So this is your coefficients, right? This was like the x squared term and the x term and the constant term. You're reducing the thing. So this is x and then the constant term. And then this is the remainder. Which is how you get to this 1x minus 2 plus remainder 5. The reason that I am going to do stuff with long division most of the time is that long division works all the time. Synthetic division only works if you're dividing by a linear thing. So like look at number 2 there at the bottom of the page. You can't do that with synthetic division because you're dividing by x squared. So synthetic division like is only defined. It's only a thing that works for a linear divisor. So I'm going to do long division. If you are comfortable with this and that's easier for you, then go for it. That's fine. What you're going to need to be able to do is if I give you a 0, that tells you about a factor. Can you take that factor out? You can do that with synthetic division. Okay. Now, again, there are a bunch of little, it's not as obvious there that there are still a bunch of little places that you can make little mistakes, right? The algorithm is kind of more of an artificial thing to remember, but there's still a bunch of little places you can make little mistakes. So again, you know, just sort of be careful about things. Let's get back to the problem that we were trying to solve though, which is that we want to find the zeros for this thing. And what we know is that -2 is one of them, right? So if -2 is a 0, then we know one of the factors because of the factor theorem. But again, you know, think about it like the graphing thing we did a little bit ago. If -2 is a 0, then what does one of the factors look like? X plus 2, right? For the usual like sign switching reason, right? If you take the factor and set it equal to 0, well, to get x by itself, you move it over. So we're just doing that in reverse. If -2 is a factor or a 0, then x plus 2 is a factor. So what that means is that this big ugly equation thing that we're trying to solve has one factor that looks like x plus 2. Because its degree is 3, if there's a linear factor, then whatever is left behind when you factor that out, which again, like we're going to have to do the hard way because none of our factoring traits work. But whatever is left behind when you take this out would have to be degree 2. It's quadratic. And we know everything about solving quadratics, right? So this gives us a way to reduce it. So let's do it. We're going to try to figure out how to take this out. The way we're going to do that is that if this is true,
Then 3x cubed minus 146x squared minus 204x plus 200 divided by x plus 2. That's a 2. That's also 2. Why can't I write 2s? There we go. Would be whatever this other stuff is. So what we're going to do is take that and divide it. 3x cubed minus 146x squared minus 204x plus 200 divided by x plus 2. Again, you can do that with long division, or you could do it with synthetic because it's a linear factor here. For the sake of doing it, let's do it both ways. I'm gonna do long division first. This into this. X squared and not just x squared, but 3x squared, right? Just looking at the leading term, so ignore everything else. Ignore everything but the highlighted stuff. What's this divided by that? 3x squared. Multiply those things. 3x cubed plus 6x squared. And subtract. When you subtract there, the leading term should fall off, right? That should go away because that was the whole point of, the step before. So those drop out, which is good. Negative 146 minus 6, so negative 152 x squared. And then I'm carrying the other stuff down because there's nothing to subtract from it, right? So it's like there's 0x and 0 there if you want, or just carry them down. And then we do it again. What's this? Negative 152x squared divided by x. Negative 152 x. Then again, we multiply this by all of this. Distribute when you do that. So negative 152x times x plus 2 minus 152x squared times 2 would be 304 minus 304x. And treat that like it's 0. Leading term cancels. Again, that's good. That's what we're expecting. That should happen. Negative 204 minus negative 304. So that becomes addition. So negative 204 plus 304 would be what, 100? And then 200 minus 0. Again, don't get in any big hurry. Do arithmetic in the calculator. The numbers here are bigger than like stuff you've seen like that. I know that part is intimidating. I'm not going to give you a thing where the numbers are quite this bad. Once we've got this though, we just do it again. X into 100x. Hundred times. Multiply that by that. 100x plus 200. Subtract, and you get 0. And the whole premise for doing the thing in the first place was that x plus 2, the thing had a 0 at -2, which means x plus 2 should be a factor, which means if it's a factor, like 2 is a factor of 6, right? If it's a factor, it should go in evenly. So the fact that we got remainder 0 here either means that we did everything right, or that like we made a bunch of mistakes that ended up balancing out in a weird way, but like that's almost never going to happen. So this is a good sign, right? So this is kind of your first check that like things are going well. What this means is that this, bear of a function that we're dealing with factors as x plus 2 times 3x squared minus 152x plus 100. Only we factored it the hard way because none of the factoring tricks or things that I know helped us, right? Once it's factored though, you can do the usual stuff, right? If I'm setting it equal to 0, that means either this one is 0, which gives us -2, or this quadratic thing that we could solve, but let's don't because the numbers are kind of a mess, like whatever, but it's quadratic, so we could solve it, right? So where we would go from here, if we were trying to find all the zeros, is to split that up, right? Use our old friend, the zero product property, and say x plus 2 is 0, so x is -2, or 3x squared minus 152x plus 100 equals 0. And we would do quadratic things, probably with quadratic formula. And you would get whatever I said they were before, 50 2/3. All right, so flip over real quick and look at like maybe like number 6 and 7 on the back. 6 says, given that 3 is a 0 of this function, find the other zeros. If I'm telling you that 3 is a 0, I'm giving you a piece of information like this, right? So what you can do with that is that factor theorem says, now like conclusively that if you know a 0, then you know a factor. So when I give you a 0, I'm giving you a factor. So if 3 is a 0, then what does one of the factors of that function look like? X minus 3. Okay, well, x minus 3 is a factor. To get the other factors, none of the like factoring by hand tricks that we know is going to work, but x minus 3 is a factor. We can divide then that function by x minus 3. You should get remainder 0 when you do, and then you've got a factor, right? Again, we had to factor it the hard way, but we've got a factor, and whatever's left should be smaller enough that we can solve it, right? It'll end up being quadratic. So the obvious to me, maybe a little less obvious to you question is, what happens on a, timed test where there's, the time crunch thing, and this problem's worth 10 points or something, and you do the division and something goes wrong. And what would tell you here that something went wrong? If the question was something like what I just read. Like I said, here's a 0, right? Here's one of them. You can have it for free. Tell me what the other ones are. How would you know that something went wrong here? If there's a remainder that's not 0, right? Because if I tell you a 0, then I'm telling you a factor. If it's a factor, then it goes in cleanly, right? It leaves remainder 0. So if you do all this division and get remainder 1, well, that means you screwed something up somewhere. Like maybe it's either, you copied the problem down wrong or something, or more likely one of the 100 places that you did arithmetic here, something went wrong. Okay, well, your choices now are like try to fix it, but like don't try to fix it. It's going to take less time to just start over. But if I take the time to start over, does that mean I'm not going to get to the last problem on the test? Because the time thing, right? What I would do at that point, like if you can just do it over, like then just do it over. But if you don't have time,
Tell me that you know what you're doing. A little arithmetic thing here is gonna cost you a point or two. Stopping there and not doing any of this, like this is gonna be half a credit, right? What happens from here on, that's half the points. If you stop here because you got remainder 1 and you know something went wrong and you just throw your hands up in defeat, that's gonna cost you a point or two for whatever happened here and half the points because of this, right? Okay, so a better idea would be, I did this.
Say hypothetically, something went wrong. I got a remainder of 1, which is bad. Hey, Dr. Thomas. What had happened was, like whatever, like say something went wrong here, but you're still going to have some kind of quadratic thing as the quotient. So go ahead and say like something went wrong, but here's what I should do next. I should take this thing and go ahead and solve it, right? And do that. Like, it's a quadratic. You can solve a quadratic, no problem. So like, go ahead and do this part. It's going to be wrong. That's okay. You did the hard stuff right. You understand the idea if you, communicate that to me that you do, that might still be like, I don't know, 7 points out of 10 or something instead of like 3, right? So this isn't the only place that that kind of, thing applies, but like, I know you kind of get, used to the computer graded stuff and like, it's either the perfect right answer or it's not, but like, I'm a human when I'm grading things. So show me that you know things and things will go better for you. Okay, hang on to those. We will pick up there tomorrow, but you know what? Give that a shot. Do this. Also, if anybody's not going to be here tomorrow, I know there's some people traveling and stuff, come grab one of these. Y'all have a good day. I'll see you tomorrow. So we'll spend some more time with a couple of these guys and then start working on this. I'm pretty happy you guys put some of this in, when we get back or something like that. I'll send you. Well, yeah, I emailed.
Oh, did you? Oh, yeah. And then I was about the midterm next week.
Do you know when you guys are leaving?
We're leaving
Okay. Okay, so there, I've got like 5 or 6 of that, so we'll have to figure out if I'm on Thursday. Just a, so tomorrow we're starting test review, so it's just some stuff we're gonna work on in class.
I'll be here tomorrow anyway, but can I have?
Yeah.